In the ChimeraX window, we have some tabs at the top that we can use for various functions. And at the bottom, we have the command bar. So if we want to open a map and model, an easy way is if you know the ID of a map, for example, this EMD0153 and EM data resource website, which has some information about the sample, the resolution. You can download the map, and if there's a model from this tab, here there's no model, so we will use one that was determined previously with a different map. So to open this map, we just type in open 0153 from EMDB, and we have the map appear. The volume viewer dialog also appears, and these dialogs can be moved around or docked on the side. And this volume viewer dialog shows us the values in the map and the contour level, which we can change by dragging the bar back and forth. And here this map is displayed with a step of 2. We want to change that to 1 so that we see the full detail in the map. In the home tab, we can change the background color, so white is a nice color for making figures. And we can change the rendering style, so for maps, the soft rendering style is actually quite nice for showing the depth. It's using occlusion lighting, which makes the inner parts darker. Now we want to open the model, and the model we will use is in the PDB. So we type open 6CVM from PDB, and the model shows up. Now we'll change back to simple display mode, which will work better for making the surface transparent. So if I click the color patch in the volume viewer for the map, the color picker should come up, and I can make the map a little bit more transparent. And you'll notice the model is not inside the map, so the first thing we will do is we will fit it into the map. And the way to do this is using the right mouse mode. We can select move model, and what this does is it will, when I use the right mouse to drag, it will perform this operation, and it will apply to the selected model. So to select the model, I can control click anywhere on the ribbon, or if I open from tools, general, model panel, this is also a useful panel which will show everything that's open. So it shows I have the map open, the model open, and I can also select the model by clicking on this checkbox here under the hand pointing at a green circle. Now if I use the right mouse, you'll notice it's moving the model independently, so I can align it. If I need to rotate it, I switch the right mouse mode to rotation, and now with the right mouse button, it rotates just the model by itself. Now if I get this close enough to the correct position, I can use tools, volume data, fit and map, and this will refine the fit, meaning that it will just move the model rigidly as to increase the cross correlation value or the density value at each atom position. So it's moving it in the gradient direction. If I press fit, it moves it, but it doesn't quite get to the correct position. It gets stuck in the local minimum. A nice way to deal with that is if we use tools, volume data, map filter, and we smooth the map. A width of 2 will bring it to roughly 10 angstrom resolution, so it will make it smoother. And now if I use the fit and map and the Gaussian map, it will move, it will avoid that local minimum and go right to the global minimum where the model fits the map very well. So I can close this. Oh, actually I will need the fit and map again. Volume data, fit and map, because what I would like to see, so let me dock this. If I drag this and put it on top of another dialog, it docks them together. Now what I just noticed is that in this version of ChimeraX 1.11, the tabs don't appear. So once I've docked something together, some tabs should appear here, so I can switch back and forth between those. I'm not sure why that is, but for now I'm going to switch over back to ChimeraX version 1.10. Now if you don't want to dock dialogues, you can keep using 1.11, but let's see what happens in ChimeraX 1.10. So I'm going to open the map again. Open the model. And now let me open the models dialog, tools, general, model panel. And if I dock these two together, you will see the tabs here at the bottom, so I can switch back and forth. Set the white background. I'm going to open tools, volume data, fit and map. And I'm going to also open tools, volume data, map filter, smooth the map. This can take a few seconds. And fit the model right into the Gaussian. And there it is. And the next thing I wanted to do was to look at how well does the model actually match this original map. So I can zoom in a little bit and take a look. Let me make the surface transparent. And we can see that it looks like it fits reasonably well. If I go to molecule display and show atoms, it will show the side chains. So I can see that a lot of the side chains have very nice densities. This is a 1.9 angstrom map, and as we see the holes and aromatic rings. We see very nice heavy atom contours. And if I lower the threshold, I should actually see some of these water molecules. But because the water molecules were built using a different map, some of them don't actually match exactly. This one here seems to do, although it's not quite in the center of the blob. And another way to calculate the match, you'll notice some of the background noise appeared here at this contour level. We can use the correlation value in the fit and map. I can open options, and here if I say use map simulated from atoms resolution 1.9, which is the estimated resolution of the map that was reported, and I can just say update, and it's reporting a correlation of 0.693. Now the cross correlation value is difficult to compare. There's no good answer across many maps and models. There's no real good answer as to what correlation value is good or what we should expect. The closer to 1, the better, obviously. You'll notice that if I change this resolution, let's say 2.0, the correlation is a bit higher, 0.702. So that can happen, but here we want to use the same resolution, and we will just compare this to the cross correlation of some of the ligand that we will look at later. Now, if we want to take a closer look at what's in this model that we actually opened, let me hide the map, and I will open Tools, General, Log. Let me dock this on top here, and I can switch so it becomes a little bit larger, and we can also put the fit and map together so all of them are all here at the bottom. If I scroll back, when I open the 6 CVM model, in the log you will see a summary of what's in the protein. So it's telling me there are 4 chains, A, B, C, D. If I click on one, it will select it, and I can do something like color, cell, which is short for selection, red, and you can visualize better the different proteins in the model. And it's telling me it's a beta galactosidase, and it's also telling me that there's some non-standard residues, including some ions, magnesium, sodium, and this ligand PTQ. If I click on PTQ, and let's make it color cell yellow, let's turn off the atoms so I can see where that ligand is better. Okay, but that also turned off the ligand atoms because the protein is shown using the ribbon. So this cartoons controls the ribbon display. It can hide or show, and this controls the atoms display, show or hide. So let me select the ligand by going back here, clicking on it, and then color this yellow. Oh, and I have to turn it on by clicking show. So because the ligand was selected when I click show, this applies only to the ligand. And I can also, to make it more apparent, I can show it using spheres. So now you can see that each protein has one of these ligands bound to it. Now before we look more closely at the ligand, let's also use the Q-score plugin to calculate how well the model fits into the map. So under tools, if you don't have the Q-score installed yet, you would go to tools, more tools, and the tool shed will come up. And here I can either search for Q-score, or if I go to model validation, the Q-score should show up. And here you would click install. For me, it's installed already. If it doesn't appear in the validation, as I noticed it didn't in the later versions of ChimeraX, I can just search for Q-score. And it's a little finicky, so Q-score. And here it is. Once it is installed, I can go to Tools, Validation, Model Map Q-score. In the Q-score dialog, I can choose the model, 6 CVM, and the map. Make sure I choose the original map, and I can just press calculate. Once the scores are calculated, they will show up on this plot, and each point represents a different residue. At the beginning here, up to residue 1000 are the protein residues, and starting at 2000 are the ligands and the water molecules we saw earlier. On the plot, if I use the wheel on the mouse, it will zoom in, and then I can see the points a little bit better. And here what we can do is we can click on a point, and it will take me to that part of the model. Here it seems to have hidden the map, so let me go back to volume viewer and show the map again. And you will notice it is zoning the map. It is restricting the surface to just the area around that residue. And if you click on a point with high Q-score, you will notice that these tend to be well fitted, well resolved in the map. This is a nice tryptophan. On the volume viewer, you can adjust the contour level and see the hole in the aromatic. And on the other hand, if I click on a residue with low Q-score, these tend to be not too well resolved. So this glutamate over here has no strong density around it. And this could be because this map being an average of many different particles, if the side chain has different conformations, if it's moving around, it will end up being blurred, so the density will not be resolved. And this is common for some of the surface residues and charged residues that may also be getting radiation damaged. Let me change the under colors, color by element. Now we can see the side chain is made up of the carbons and the 2 oxygens on the end. Now first, let's say I want to go back to the full molecule display and the full map display. I can undo this zoning by typing vol, which is short for volume, on zone, and the ID of the map, which I can see under models. This is map ID number 1, and this will go back to showing the full map. However, there is a bit of clipping going on, and I can undo that by just typing view and that resets the view so it includes everything that's visible. And to show the entire molecule, first I'm going to control click outside so nothing is selected. Now under the Home tab or Molecule Display, if I click Hide, it will show all of the atoms as before. If I click Show Above Ribbons, it will show the ribbons as before. And let's select the ligand now. Select, and I'm going to be specific and say in model number 2, which is our atomic model number 2, which actually I could leave out because there's only one model open right now, so I can just say the shorthand for selecting a chain is /A, and then semicolon and either a residue number or a residue name, so I can say PTQ, and this will select the ligand in chain A, in protein A. If I see it, I can zoom in onto it, or I could do something like view cell, and that will take me to where that ligand is. Now let's say I want to show just the density around this ligand. I can use the command volume zone, the ID of the map number 1 near, and now I can say a selection. I can say either a selection or I can say specific atoms. I'm just going to say cell for selection, and then I can give it a range, so within 2 angstroms. And if I want this to appear as a new map, I can do new map true. And if I want the map not to have the original size of the full map, which is rather large, I can say minimal bounds true. And now this will generate a map of just the ligand, and I can control the contour level of the map by itself and make it transparent and gray. And now to show just the ligand by itself, I can use a shortcut command, which is not show, not cell. It's still showing the ribbon, so for that I have to replace the show to not rib, not cell, and now I can see just the ligand by itself. Now when you've zoned the map this way, we have to be careful that we don't lower the threshold too much. This might make us think that there is a lot of density around some atoms, but if I'm careful and I stay at high contour levels, these densities actually represent strong density values. And what you might notice visually is that this part of the ligand fits into the density rather well. It is a little bit noisy and broken up, but this part of the atom looks a little bit like it doesn't fit so well. This contour is a little bit larger than what that atom is. This atom is sticking out. This arm over here is not really in the density, and this carbon and oxygen are also not very well fitted. And you will notice that there's this aromatic ring. There is a hole that is not quite centered on where the ring is. Another way to test this is if we go back to the fit and map dialog, and let me undock this, and here we say fit selected atoms into the original map, and we just want to update the correlation only for the selected atoms, and this goes down to 0.666, which is quite a bit lower than 0.7, which means that the model of the ligand does not seem to fit the density quite as well. Now, in order to change the model and see if we can fit it better, we can use ISOLDE and Clipper. So first of all, if we haven't installed that yet, we go to Tools, More Tools, back to the tool shed, and you will notice ISOLDE and Clipper are some of the top downloaded plugins bundles. And if I click on ISOLDE, it will take me to the screen where I can click the install button, and similarly Clipper, which is also required. I can install that separately. Once those are installed, the first thing to do is to associate the map and the model that we want to fit together. So the command for this is clipper associate, or for short, and then the map ID and the model ID. Oh, I forgot to put to model. And what this will do is you will notice the map and the model are now grouped together. The map is under Map Manager, and the map appears like this meshed transparent surface. If I turn it off, that goes away, and the model is now model ID number 1.2, and it showed all of the atoms again. So with PTQ still selected, I can hide those, not show, not cell, and not rib, not cell. Now the next part is ISOLDE uses molecular dynamics, which requires hydrogen atoms. So just in case the hydrogen atoms are not in the model, I can type the command add H, and this will add them into the model. Often the hydrogen atoms are not included in the model because there are a lot of them, and they can be easily added back as needed. Now you'll see some hydrogens appear here on the oxygens, and the ribbon appeared again, so I can say not rib, not cell. If I type show H, it will actually show all of the hydrogens. By default, some of the hydrogens connected to carbons are not shown. Now the next thing is under the ISOLDE tab is I can start ISOLDE, and this appears as its own panel, which I can bring over here to the side. And the next thing to do is to, with the PTQ ligand selected, if I press start, it will start simulating this ligand by itself and its nearby environment. However, we have a small issue in that some residues do not match the template, and if I press OK, the ISOLDE window will go to the validate unparameterized residues, and it will show me a list of the residues that don't have parameters or don't match the template. If I click on this residue GLN, it will also show me a list of possible templates, and I can click one of them and I can say rebuild residue to template, and optionally I can say do it for all residues of this name, and there's a couple in the other chains. So this will now make that residue match the known template. For PTQ, there are no possible templates, but there is a shortcut in ISOLDE param cell, which will build the parameters for the ligand, and it can do this for many types of ligands. It's using an external software, and now the parameters should be set. So now with PTQ selected, I can press start, and it will start simulating, and you can see that the ligand is wiggling around. And what's happening here is ISOLDE is simulating movement over all the atoms and is trying to push the atoms towards higher density points in the map while keeping the model well formed. So keeping bond lengths, keeping bond angles close to known optimal values. We can see that it didn't change the model too much in this case, and if I stop the simulation, I can go back to fit and map, and let's see what the cross correlation is now for the ligand against the map. Fit selected atoms into the original map, which is now 1 1 1 1, and use map simulated from atoms as before, and update, and we can see it actually went down even a little bit, 0.59. So why could this happen? It could be that the nearby atoms have pushed it around a little bit, and we can show those nearby atoms by with another zone command without the volume. This time it's just zone cell, and this will show me some of the nearby residues, and we can see this pocket is quite crowded. So during the simulation, because the initial confirmation may not have been correct, it actually got pushed out of the density even more. So what could be wrong? Well, one thing we can try, again, this part of the ligand seems to be well fitted, but this part, it could be that a rotation around this bond could improve the fit. And if I control click outside and now control click on the bond and I click adjust torsion, in the build structure dialog I can rotate the knob to rotate around that bond. However, it's rotating the wrong end, and I can switch that by clicking on this bond field and say swap moving fixed sides, and now I can rotate the ring on the other side. Let's try a 180-degree rotation, and if I select, a shortcut for selecting the ligand is control click on an atom and then pressing the up arrow, and that selects just the ligand. And I will start the simulation again just with this ligand. And now we can see it's actually snapped into the density pretty nicely. Now the hole in the density matches a little closer to where the hole in the model aromatic is. These heavy atoms are actually fitting more nicely into the map. There's still a small issue over here. This elbow seems to be going the wrong way. And in ISOLDE, once with the simulation running, it sets the right mouse to dragging atoms. If I right mouse click here and drag it, it will nudge that atom in the direction I am dragging. And now it really snaps nicely into place, and we can see a very nice fit. And if I go back to the fit and map dialog with PTQ selected, for the selected atoms in the original map, and I say update, now the correlation has dramatically improved to 0.78, which is more in line with what we saw as a cross correlation for the entire model to the map. So that was a quick exercise at looking at a map and a model and doing flexible fitting. Well, first doing rigid fitting in ChimeraX and then doing flexible fitting with ISOLDE and Clipper.